here's what we're going to be doing today. The learning objectives are to be able to graph lines written in either the y equals mx plus b, which is the slope intercept form, or the ax plus by equals c form, which is called the general form. Usually, most of the time, we write things in this form, but sometimes things are in this form. And I will actually mention that in this form, the slope is m. In this form, we don't know what the slope is right off the top of our heads, right? The slope is not capital B in this form. You'd have to do some work to solve for the slope. We also want to be able to find the equation of a line through 2 points. We also want to be able to graph a parabola in the what's called the standard form, the y equals ax squared plus bx plus c form. And then the last objective is to be able to find the points where two graphs intersect. So those are the main things we're going to try and walk away with from class today. I feel like that sentence wasn't great. There's probably a couple other things that will also get thrown in there. I feel like I'm also weirdly off camera, but you know, that's the way it is. So I feel like it's weird to be like this disembodied voice way out here, but sometimes I will be off camera. So such is life. So that's what we're doing today. Actually, I want to erase this first. I like taking notes. You're obviously welcome to take notes, but you obviously also don't have to take notes because all the notes are on Canvas for you. So that said, I'm the kind of person that learns things by writing them down for myself. So if that's you, I encourage you to take notes. If that's not you, don't waste the paper. So what I want to talk about first is the two forms. So forms of lines. So the form we're probably all most familiar with is what is called the, people often just call it the y equals mx plus b form, but it's also called the slope intercept form. And the reason it's called that is because literally, if your line is written in this form, it is obvious what the slope and the y-intercept are. So this here, that's the slope of the line. And this here, that's the y-intercept. Or if you prefer, you can say that the y-intercept is the point 0, b. So it's a form that kind of has a lot of information already very visible to us. And then the other form that we often see is this form, the ax plus by equal to c, which is called, usually it's called the general form. And we'll do a little bit of lines written in this way. We'll graph some lines written this way. And we'll see that no matter which way you write the line, we can still find what we need. A noise happened. Oh, I think I know what it was. No, I don't know what it was. Sorry, there's new noises and I'm trying to get used to them, but I will try to make sure I don't get all freaked out. Sometimes noises happen and they scare me, so you might see me jump. One time a wasp stung me in the neck when I was in a meeting because it apparently latched onto me while I was outside and came back in, and all of a sudden I was like, oh my God, a wasp. It was a little, in fact, still in my windowsill dead because I left it over there, but as a warning to the other wasps. So I will mention there is one other form. It's usually not the form we write the line in, but you can also write a line in the form which is called the point slope form, which is y minus y1 equal to m times x minus x1, where the line goes through the point x1, y1. This is a very useful form. In fact, it's the way I like to often leave my lines, but it's not kind of, we often don't end there because it's not unique, right? If you're finding the equation of a line, there's a lot of different ways you can write it using the point slope form. whereas there's only one way you can write a particular line in the slope-intercept or the general way. So this is useful, but we'll talk about it more in a minute. So these are the two forms, and we're going to graph some lines. And here's what I want to say about graphing lines. There's a lot of ways people like to graph lines. You should probably do it whatever way works best for you. The way I personally think works best is to graph the line by finding the intercepts. Because to graph any line, if you know it's a line, you only need 2 points. And usually when we are asked to graph things in general, people who are asking you to graph things usually want you to tell them what the intercepts are. So if you're going to have to find the intercepts anyway, those might as well be the points that we find to graph the line. You could really find any 2 points and draw the line through them, and that would be fine. And I'll kind of show you that a little bit later. But let's do that for these two. So I'm going to erase this here and move that a little bit. So for this first line, I want to find the Y-intercept. Now, we already know the Y-intercept because it's written in the slope-intercept form. The Y-intercept is 4. But I should mention the way we find the Y-intercept is always the same. We're going to find the Y-intercept by setting x equal to 0. We always find the Y-intercept by setting x equal to 0, no matter what kind of graph we're graphing. Because if you set x equal to 0, you haven't moved left or right. So you're on the y-axis. And that's how we find the y-intercept. So if I set x equal to 0, y equals 2 times 0 plus 4. Oh, y equals 4. Trying to use colors appropriately here. So there's my y-intercept, 0, 4. Sure. To find the x-intercept, we do the same sort of thing. To find the x-intercept, well, if I want to find where I am on the x-axis, I haven't moved up or down, so I'm going to set y equal to 0. Usually, at least in this form, finding the x-intercept is a little bit more work. If we set y equal to 0, I'm going to have 0 equal to 2x plus 4. I can subtract 2x from both sides and get negative 2x equal to 4, or x equal to 4 divided by negative 2 is negative 2. So there's my x-intercept at negative 2, 0. And then to draw the line, we just try and draw the straightest line we can through those 2 points. This is always the part that's challenging. Oh, I kind of missed. And my line doesn't look very straight. That's okay. Yeah. So let's do the same thing for this other line. So you'll notice, well, actually, I should say a couple things before we do that. So this line in red, the slope is 2, right? There's our slope right there. Coefficient of x, y equals the slope times x plus b. And we notice that when you think about slope, there's a couple of ways to think about it. I'm thinking of it as the rise over the run, or how much y changes for each 1 that x changes. So if I go over 1 with a slope of 2, that means I'm going to end up going up 2. So over 1, up 2, and then over 1, up 2. So that's kind of what it means for the slope to be 2. For every increase in x by 1, the y increases by 2. And I want to point out, for this blue line in the general form, the slope is not 3, because it's not written as y equals something times x plus b, right? So I don't know what the slope is here yet. We're going to find it, but we don't actually need it to graph it. So if I'm just graphing this line, all I need are the intercepts. To find the y-intercept, I'm going to set x equal to 0. And then I'm going to get, well, if x is 0, this whole term, 3 times 0 is 0. So I get 2y equal to 8, which means y is equal to 4. And I feel like I made a mistake. I did. It's all right. I made a mistake in the, I didn't really make a mistake. I wrote down the wrong line I wanted to graph, but that's fine. It doesn't really matter. So y is equal to 4. And then for the x-intercept, I'm going to set y equal to 0. And if I set y equal to 0, I get 3x plus 0 equals 8. And dividing both sides by 3, I get x equal to 8/3. So I have the point 0, 4 right there. And then I have the point 8/3 comma 0. Now, 8/3 comma 0 is not the nicest point to graph, right? It's probably like about right, I don't know, right there. Almost 3, but not quite. And then I'm going to draw the line between them. Now, in this particular example, it's really easy to see where the lines intersect because they happen to have the same y-intercept, which is not intended, but is what happened. Something else I want to say. Oh, what is the slope of this line? Well, we could find the slope if we wanted to by solving for y. So you could say 2y equals negative 3x plus 8. And then y equals negative 3 halves x plus 8 divided by 2 is 4. So if I write it this way, which is the same equation, just written differently, it's easy to see, oh yeah, the y-intercept is definitely also 0, 4. And the slope is negative 3 halves, meaning for every 1 I go over in the x direction, the y value is going to go down by 3 halves. So like if I start here, if I go over 1, I've drawn this point in the wrong spot here. If I go over 1, I'm going to go down 3 halves. If I go over 1, I'm going to go down 3 halves. So that's one way you can think of the slope here. All right. Yeah. Let me talk about, if I wanted to figure out, so I'm going to pretend like we don't know where these intersect, even though they obviously intersect at 0, 4. But I'm going to pretend like we don't know that. If I was going to try and solve where these intersect, it would actually be a little bit of work. So the question we're asking, where do y equals 2x plus 4 and what was the other one? 3x plus 2y equals 8. Where do these intersect? One way you could do it would be by solving this equation for y and then setting the equations equal to each other. And that'd be a perfectly fine way of doing it. That's not that I'm going to do it because I want to show you a different way, but that's often what people would do. Another way we would say, oh, y equals 2x plus 4, and I'm going to substitute that in for y right there. So then in this equation, 3x plus 2 times y, which is 2x plus 4, is equal to 8. Right? We're just jamming that in right there. That's your y. And then we can solve this equation for x. We get 3x plus 4x plus 8 equals 8. 3x plus 4x is 7x. Subtract 8 from both sides and you get 0. So you get x equal to 0. And then you can plug back in 0 for x into either one of these equations. If you plug it in here, y is 4. If you plug it in here, 2y equals 8, which means y equals 4. So yes, the point 0, 4 is where they intersect. Do they have to intersect? I guess that's not a great question. These lines do have to intersect. Do lines in general have to intersect? No, they could be parallel. And more generally, depending on what types of graphs we're talking about, like we're going to talk about parabolas and lines in a second, they may or may not intersect depending on where they are oriented. Let's see, what else did I want to say here? Oh yeah, okay. So there's not a whole lot else to say about how to graph lines. I personally think you should graph lines by finding the X and Y intercepts, because at least for me, when I ask you to graph a line, I'm going to ask you to find those points anyway. So if you already have to find those 2 points and you only need 2 points to graph a line, you might as well do as little work as possible and find those 2 points. I'm a big fan of doing the math as efficiently as possible. I will still show you all the ways, but I will talk about doing it the way that is the most efficient. I also wanted to mention, especially for this particular set of notes, there are a lot of videos on Canvas of how to do things that do not feature me. They feature a former colleague of mine who's really great. Her name is Jen. So if there are things that we either don't get to or you need more help with, definitely take a look at those videos. They're there for you. I'm also available, but just want to let you know there are lots of helpful videos. I mean, there's lots of helpful videos on the internet in general about how to do lines and parabolas and stuff, but there's also specific things on Canvas for you. So how about the equation of a line through 2 points? Specifically, the points I want to pick are so the equation of the line through the points, what do we got here? -3, 1, and 4, 5. And the thing I want to remember, or kind of I want you to take away from this, is to find the equation of a line, you really need 2 pieces of information. So we need a point. You always need at least 1 point to find the equation of a line. Otherwise, if you didn't have any points, you wouldn't really kind of have anywhere to anchor it. And then the second thing we need is the slope. Once we have these 2 pieces of information, we can totally write the equation of the line. So do we have a point? Yes, we do. In fact, we have 2 points, but we need to find the slope. So the way we're going to find the slope is to use the slope equation between these 2 points. So yeah. Sure. I kind of want to draw it, even though I wasn't going to do that just yet. I think I am going to do it. So if I draw this real quick, let's see. Say this is the point -3, 1. Over here is the point 4, 5. Right, there's the line that's going between them, and the slope is this change in y, or delta y, over this change in x, or delta x. So I'm trying to figure out how much change in y per how much change in x. And the way we're going to calculate that is by doing the difference in the y's, y2 minus y1, divided by the difference in the x's, x2 minus x1. And it actually doesn't matter which way you do it, meaning you could do it y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Well, so I have a question for you guys. Do I sound at all crackly or like there's any interference in my microphone? Okay. Sometimes there's a lot of like electronic things near my microphone, and sometimes I think I put my actual phone too close to my microphone and it makes it kind of like So if you hear weird feedback or something, let me know and I will try to fix it. But good. So when you do this, the only thing you have to make sure is that you subtract the same order for the y's and the x's. And you also have to make sure the y's are on top. I've often made the mistake of actually accidentally doing the x's on top because the x's come first and it's kind of have to be like, oh yeah, this minus that. No, you have to do either, so the y's first, so I can do 5 minus 1 over, now if I do 5 first on top, I have to do 4 first on the bottom. Or you could do 1 minus 5 over negative 3 minus 4. Either way, so for this one, you'll get 4 over 7. For this one, you'll get negative 4 over negative 7, which is the same thing. So now we have our slope. It's 4/7. So when I read this slope being 4/7, it means if I go over 7, I go up 4 because my run is 7 and my rise is 4. And now I want to actually write the equation. So we've got the point, we've got the slope. So this is actually one of the times where you can really go, oh. So the recording doesn't upload right afterwards. It automatically records to, I have it recorded not to the cloud, but to my computer, because I prefer to edit it just a little bit so that I can kind of take out some of the fluff at the beginning and fluff at the end. So I do teach a class right after this, so probably won't get uploaded until more like 4 or 5 o'clock-ish is when it should be available, just so you know. Good, thanks for asking, Jonathan. So to find the equation of the line, there's actually 2 different ways you can do it. You can either you can start with y equals mx plus b. And say, okay, I know the slope is 4/7. And then you can pick either one of those points to plug in for x and y and then solve for b. So I'm going to do it the opposite way I did it in the notes here, just to change it up a little bit. So I'm going to plug in not this point. No, actually, I'm plugging it up. I'm not going to do the opposite way. So I'm going to plug in 5 for y and 4 for x and solve for b. So 5 equals 4/7 times 4 is 16/7. And I'm going to subtract this over, and I'm going to get a common denominator. So I'm going to make 5 35/7. I multiplied 5 by 7 over 7. I'm going to subtract 16/7. And then 35 minus 16 is 19/7. So the equation of my line would be y equal to 4/7x plus 19/7. If you do it this way, which is perfectly fine, it's necessary that you go back and actually rewrite the equation with your b value actually plugged in for b. Right? If you stopped here, it wouldn't really be complete. I'm doing a lot of talking today. The other way you can do this, which is probably my preferred way, is to use the point slope form. To say, okay, I'm going to do y minus y1 equals m times x minus x1, plug in an x1 and a y1, and then isolate y. So I'm going to use this point here just to change it up. So I'm going to do y minus 1 equals the slope, which is still 4/7, times x minus negative 3. And then I'm gonna isolate y. First, I'm going to distribute this. So I have y minus 1 equals 4/7 times x plus 3. This distributes to each of those terms. So y minus 1 equals 4/7 x plus 4/7 times 3 is 12/7. And then I'm going to add 1 to both sides. So y equals 4/7 plus 12/7 plus 1, which is 7/7. And then I think I can fit this in here. I get y equal to 4/7 x plus, oops, I forgot the x here. That's not good. 12/7 plus 7/7 is 19/7. So either way you do it, whether you write it like this and solve for b, or you use the point slope form and just solve for y, you're still going to get the same thing eventually, assuming that the work is correct. So I don't care which way you do it, just do whatever you like. I prefer to do it this way because I don't like having to plug back in b once I've solved for b. But if you like it this way, do it this way. Let's see here. Few last things about lines. And I said this, well, I didn't say this actually. So parallel lines have the same slope. So for example, what do we got here? Y equal to 2/3 x plus 1, y equal to 2/3 x minus 5, and 2x minus 3y equal to 7. These are all parallel. The first two, I think, fairly obviously, because we can totally see without doing any work that the slope here is 2/3 and the slope here is 2/3. The last one, it's less obvious, but it is true that the slope here is also 2/3. We could solve for y and see that the slope, that the coefficient of x is positive 2/3. And then another thing that is true, perpendicular lines have slopes that are negative inverses. Or I usually say reciprocals actually. Negative reciprocals. So these two lines, y equal to 2/3 x plus 1 and y equal to negative 3/2 x plus 5 are, that's a symbol we use for perpendicular because we don't like to write out the long word perpendicular. Another example would be y equal to negative 3/4 x plus 2 and 4x minus 3y equal to 8. These are also perpendicular. So here, the slope is 2/3 and this slope is negative 3/2. It's the negative reciprocal. Here, the slope is negative 3/4. And if we solve for y, the slope here would be positive 4/3, the negative reciprocal of negative 3/4. All right. I was hoping to fit more on this board. I feel like, well, no. I kind of feel like I take up too much space when I write, but I don't actually think I write too big. I just don't use the space efficiently. Because I don't think you want me to write smaller. I think my writing is probably already too small. Last couple things about slopes of lines. So y equal to c, where c is a constant, so like y equals 5, is a horizontal line. And has a slope of 0. And the way I kind of think about a horizontal line is you've got 0 rise over as much run as you want, right? The rise over the run is 0 over any number you want, which is just 0. Right? We get no rise, all run. On the other hand, x equal to c, like x equal to 2, is a vertical line. And it looks something like this. And it has an undefined slope. All rise over 0 run. And we know, or hopefully, if we didn't already know, we know now that dividing by 0 is a big problem, right? It usually leads to being undefined in some way. Okay. And as usual, even though I wanted to get started really fast, definitely taking longer to say the things than I had hoped to. It's all right. That's just the way it is. So let's move on to talking about graphing parabolas. Take a drink of water. So y equals x squared is what I usually call everyone's favorite parabola. It's the nicest one. It's easy to draw. It's got a vertex at the origin. It's also what we call a parent graph. I think it's perfectly fine to not plot a lot of points when you graph a parabola. And just be like, well, there it is. And you don't have to be like, you know, here's 1, 1, here's 2, 4. No, we don't need all that. You just need kind of a few things, which I'm going to point out right now. So when we graph a parabola, or I should say to graph a parabola, this pen is not great. There are 3 things I want you to focus on. The first and most important is finding the vertex, which in this parabola is that point right there. It's either the lowest point if it opens upwards or the highest point if it opens downwards. Second thing, Y-intercept, which is usually pretty easy to find. And then the third thing, the X-intercepts, if they exist. Because sometimes we can have a parabola that doesn't cross the x-axis. Let's look at an example. So let's graph the parabola y equal to, what do we got here? X squared minus 2x minus 8. There's a couple ways to find the vertex, but usually the easiest way is what people often call the negative b over 2a method. So for the vertex, I like to write the x coordinate as v sub x. And to find the x coordinate of the vertex, it's going to be negative b over 2a, where I suppose I should be more specific, right? We're thinking of this as being written as y equal to a times x squared plus b times x plus c. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant term. So in this case, our b value is negative 2, and our a value is 1. So I get 2 over 2, which is 1. And then we have to find the y coordinate. The y coordinate we find by plugging in the x coordinate back into the equation of the parabola. So we're going to plug in v sub x equal to 1 to get v sub y equal to 1 squared minus 2 times 1 minus 8. which is 1 minus 2 minus 8, which is negative 1 minus 8, which is negative 9. So the vertex is the point 1, negative 9. And that's the most important point of the parabola. The other points are important as well, but this is like the most important point for sure. So then we also want to find the y-intercept. The y-intercept, when it's written like this, is really, really easy to find. If we plug in 0 for x, well, if x is 0, we're going to get 0 minus 8 for y. Or more generally, if it's written in this ax squared plus bx plus c form, the y-intercept is always just the constant value c. So our y-intercept is the point 0, negative 8. And then here's what I really think is a good idea. Plot these points before you think about the x-intercepts. Okay, I don't have enough room to do on this side. So I'm doing y equal to x squared minus 2x minus 8. My vertex is down here at 1, negative 9. And my y-intercept is here at 0, 8. And there's a couple ways you can think about this. You can either say, well, I know the vertex is the highest or the lowest point, and it's clearly got to be the lowest here because there's a point that's above it, the y-intercept. So that means it's got to open upwards, it's got to cross the x-axis and have x-intercepts. So we're going to find them. The other way you can think about it is, if you look at the coefficient of x squared, if it's positive, that means the parabola opens upwards. So since this a value is positive 1, that means we have an upward opening parabola. So once you know that the vertex is down here and you know it opens upwards, we also know that we're going to have x-intercepts. So to find the x-intercepts, we're going to set y equal to 0. So we're going to have 0 equal to x squared minus 2x minus 8. And usually the way we're going to find these is by factoring. Not always. Sometimes things don't factor. If they don't factor, use the quadratic formula. But here we're going to factor. This factors as x minus 4 times x plus 2. So I get x equal to positive 4 and x equal to negative 2. So my intercepts are at positive 4 and negative 2. And then we try to draw, we try to draw a better problem. So my parabolas have looked better in the past. This one's all right. That's how we draw parabolas. Find the vertex, find the y-intercept, x-intercepts, if there are any, and then graph the thing. I will say there are obviously a lot of graphing tools at your disposal, and I think it's really good to be able to look at this equation and be like, I know what that looks like without having to use a graphing tool to kind of know. That said, it's perfectly reasonable to kind of check the work you've done using some graphing tool. So don't feel like you can't use graphing tools to do it, but definitely try to do the work on your own before you kind of fall back on like, well, what does this graph actually look like? So that's all I really want to say there. I wish I had more time. I often will want to say, I wish I had more time. To feel like we're not getting to all the things we were supposed to get to today. So I will probably make a video or two after class, just so that there's a little bit more content for the things we didn't quite get to in the notes. There's also plenty of videos on Canvas about some of the things we didn't quite get to. But I do want to give you one more example. So let's look at this parabola. Y equal to x squared minus 4x plus 5. So I want to graph this. And we do the same thing. First, I'm going to start with the vertex. The x coordinate, so v sub x, is negative b over 2a, which is negative 4 over 2 times 1, which is positive 2. The y coordinate, make sure everything's in here. I'm going to plug in that 2. So I'm going to get 2 squared minus 4 times 2 plus 5. That's going to be 4 minus 8 plus 5, which is negative 4 plus 5, which is 1. So there's my vertex at 2, 1. And at this point, you might say to yourself, I know this parabola opens upwards because of this leading coefficient being positive. So I know I don't have any x-intercepts. Or you might go a little bit further and say, what's the y-intercept? Well, the y-intercept, if I set x equal to 0, I'm going to get y equal to 0 minus 0 plus 5, which is 5. So I get the point 0, 5, which is up here. So now I have even more evidence that, oh, well, if this is the vertex, it's either the top or the bottom. I know it's got to be the bottom because it's not the highest point. So this graph is going to look like, oh, wow, it's going to look better than that. And usually, if I have a graph that doesn't have any x-intercepts, I should say if I have a parabola that doesn't have any x-intercepts, I often like to throw on one additional point. It's not required, but it is kind of nice. So this is the point 0, 5, and this is the point 2, 1. I often like to include kind of the mirror image of this point over here. So I want this point, which I know has a y value of 5 because it's at the same height. And instead of being, 2 to the left, it's 2 more to the right. So it's going to be the point 4, 5 because they're equally spaced from where the vertex is. The last thing I want to say, I know it's 2 o'clock, so we're out of time. The last thing I want to say about this example here is that the minimum value of this y equal to x squared minus 4x plus 5 is, well, it occurs at the vertex. The minimum value is y equal to 1. That's the smallest value the graph of the parabola can have. And I would say it occurs at x equal to 2. So when people talk about minimums or maximums of functions, there's kind of 2 different ways of thinking about it. We often talk about the minimum occurring at the x value. So it occurs at x equals 2, and it has the minimum is what the y value is. So the minimum is y equal to 1. If this were a downward opening parabola, there would be a maximum value at the vertex. Well, I would love to say more, but it's 2:01.